Alright, let's continue with our induction motor part 2, which is still on the basic material. Now, in this part 2, we want to talk about 3 items. How to calculate the rotor current. Remember, voltage was induced in the rotor, and therefore, there is a current. How to calculate the rotor current. And how to calculate the maximum torque when it is running. Now, what is the condition to make our motor run at maximum torque? Third, how to find out what is the maximum torque at starting. Starting means when you switch on the motor, it's starting. So these two are very different conditions. This one is when it's running, this one is at starting. Now when is it that you need a maximum torque at starting? For example, if there's a crane and you want to lift up a heavy container, right? And you're using a motor to lift it up, and that's the time that you need maximum torque at starting. Right? Okay, let's talk about rotor current. Alright, so that will be our point number 5. To find the rotor current, you must know the basic diagram, the equivalent circuit diagram. Okay, now I will say that for point number 5, it's better that you remember the diagram than the formula. Yeah. Now, in this diagram here, how do I calculate the current? I use Ohm's law, V divided by Z. Who is the V? ER. Who is the Z? It's the combination of both, right? They are complex number. Impedance triangle, this is R plus, sorry, it's not RX, it's R2. R2 plus JXR. So using Pythagoras theorem, it is R2 squared plus XR squared. Got it? Looks quite complicated, right? But it's actually an Ohm's law formula, voltage divided by impedance. Okay? Remember the diagram, perhaps make it easier for you to remember this formula. Alright, now, let's come to the English word, because otherwise, this will not spring out in your memory. Now, this is a voltage, rotor voltage, when it's running. Okay? When it's running, it depends on the speed. The higher the speed, the higher is the voltage generated, right? So ER is equal to SE2. What is S? S is the slip. Can you remember slip? Slip is equal to NS minus NR over NS. Right? So slip is actually speed dependence. What is E2? E2 is the standstill voltage. That is to say, when the motor, before it starts moving, at 0 RPM, what was the initial voltage? So that's called a standstill voltage. So ER is equal to SE2. S is the slip and E2 is the standstill voltage. Okay? What is R2? It's the resistance of the rotor winding, which we call it the standstill resistance. Because now motor, and this resistance value will not change. You don't have to multiply by slip because resistance is frequency independent and therefore speed independent. It doesn't depend on the speed. So R2 is always the same value. Whereas inductance will change. Remember your X is equal to 2 pi FL, right? 2 pi FL. Yes? And if frequency change, X change. Right? And frequency depends on the slip. And slip depends on the speed. So XR, the reactance, is equal to SX2. What is S? The slip. What is X2? The standstill reactance. Yeah? So remember, diagram will give you the Ohm's law formula. Okay? Don't try to memorize this formula. I think it's a bit too much. Yeah? From this diagram, how to find the total impedance? Pythagoras theorem. Remember that these two parameters are dependent on the slip. Yeah? Slip is equal to NS minus NR over NS. Alright, point number 6 about the torque condition. Okay, what is the condition for maximum torque when it's running? Okay, now the condition is that the motor must achieve the slip is equal to R2 over X2. If you know the value of the standstill resistance and the standstill reactance, you divide them. Let's say the answer is 0.03. That means to say when induction motor is running at this particular slit, then the motor will run at the maximum torque. Right, so that is the condition to achieve maximum torque when it's running. Okay, point number 7. Maximum torque at starting. Right? Now this one is about initial. That means when you turn on your induction motor, you want your induction motor to develop maximum torque. Now that condition, it must be achieved is that R2 must be the same as X2. R2 must be the same as X. The two values must be the same. If they are not the same, you add an external resistance or add an external resistance to make them the same. For example, if this is equal to 0.3 ohm and this is equal to 0.7 ohm, they are not the same, right? How to make them the same? You add an external resistance to it, which is 0.4 ohm. Right? You make them the same, and then the maximum torque will occur. So that is the part 2, which is how to find the rotor current, what is the condition for maximum torque, what is the condition for maximum starting torque. Right? So let's try some questions on these 3 new facts. Okay, again I'll refer to the tutorial question so that we are on the same, we will revise the same formula. Okay, so it says here, this example, a 3-phase 4-pole induction motor is star connected and the line voltage at standstill on an open circuit. Okay, so it says the line voltage, line voltage at standstill is equal to 520 volts. The rotor resistance per phase is 0.4 ohm at standstill and the reactance per phase at standstill is 2 ohms. Okay, calculate the rotor current and the rotor frequency when the motor is running. So you ask to find the rotor current, okay, and the rotor frequency when the motor is running. When rotor is running at 1420, 1425 RPM. Right? So now how do we solve this? Now remember we say we must have the diagram in mind, the series circuit in mind. Right? So if you have the diagram in mind, the diagram will look like this. Okay, so there's ER, which is equal to SE2, and there's XR, there's SX2, and there's R2. Right? So this is the rotor current per phase. Yeah? So rotor current per phase. So first of all, we need to know the slip value. To know the slip value, slip is equal to NS minus NR over NS. I'm given NR 1425. So NR is 1425. How do I calculate NS? NS equal to 120 F over P. Right? And F is given is a 50 Hertz question. Yeah? So F is given, number of pole is given, core is given. Right? So NS can be found. So slip can be found. Right? And slip can be found. Alright, then you ask yourself, what is E2? E2 is a standstill voltage. Now the question says the line voltage is 520. Now this circuit is single phase. So you must find the phase voltage. Phase voltage will be line voltage divided by square root 3. So it's 520 divided by square root 3. Right? So therefore, IR is equal to SE2 divided by Pythagoras theorem, R2 square plus SX2 bracket square. Have I got slip? Yes, I calculated it. Have I got E2? Yes, I calculated it. R2 is given, slip calculated, X2 is given. So current can be found. Right? Then you're asked to find the frequency of the rotor voltage, which is equal to S times F. S we calculated, F is 50 Hertz, so the answer is out. Got it? So that is part A. Part B. Alright, it's the same exercise, but part B now. Right? It says when NR is equal, is not 1425, but NR is standstill. What's the meaning of standstill? Standstill means NR equal to 0 RPM. It has not moved yet. It has not moved yet. Right? So you redo your mathematics. Right? This time, what is NR? Equal to 0. It's equal to 0. Yeah? Slip is therefore equal to 1. Slip is equal. Oh, when motor hasn't moved and the slip is always equal to 1. Right? Then you redo your calculation. This time slip is equal to 1. 1. Right? And you get the answer. Right? And slip is equal to 1. 1 times 50 is 50. Right? So that is the example to illustrate to how to find the rotor current. So let us now go through an example to find a torque condition. Alright? If I'm going to give you R2 and X2 value, yeah, R2 and X2 value, okay, it says that R2 is equal to 0.3 ohms and X2 is equal to 1.2 ohms. Right? It's a 4-pole machine at 50 Hz, 3-phase, and the slip is equal to 5%. Okay? Alright, A. Find the slip and speed at which maximum torque occurs. Right? When this maximum torque occurs, find slip, find speed, find the speed, and find the slit. Okay, now maximum torque, what's the condition? If you still remember, S equal to R2 over X2. So in this case here, it's equal to 0.3 over 1.2. Right, 0.3 and 1.2, and I have the answer is 0.25. Right? And find the speed. Speed means NR, right? NR is equal to 1 minus S multiply NS. So that's 1 minus 0.25. How do I calculate NS? 120 F over P. Right? F is 50 and P is equal to 4. Right? So with that I find P. NR is 1125 RPM. Okay? So this exercise illustrates to you how to calculate, how to use the condition for maximum torque. Right, next exercise. Same question. But now you are asked to find what is the external resistance needed. So external resistance needed to achieve maximum starting torque. Okay. Now maximum starting torque, that is a different condition. It's a different condition, right? To achieve maximum starting torque, right? R2 must be the same as X2. If they are not the same, you put an external resistance, and that's what the question is asking you. So my resistance is 0.3, my reactance is 1.2. So what must I add to make it the same? Of course, the answer is 0.9. Am I right? 0.9 plus 0.3 is 1.2. So therefore, the external resistance needed is 0.9. Will do? Yeah. Okay, that is the 3 new points that we just learned.